hoping everyone is still surviving the COVID situation that's out there. We'll keep letting them in, finding ways to stay socially connected. I am the North America DevOps Solution Factory Lead for Accenture out of the Tampa Advanced Technology Center. We put this meetup together to bring folks in the Tampa Bay area together to talk about all things DevOps or even anything modern engineering. We get to work with some of the latest technologies and, across not only where at Accenture, but across Tampa in general. And we just like to be able to share what we're doing across those different areas. If you're interested, we're always looking for speakers. Drop me a note. It doesn't have to be, a huge topic. It could be something small, something big, something around transformational, something that's maybe Docker or something, that we're getting into from a DevOps perspective that you think other folks might be interested in. I'm pretty relatively easy to get a hold of. Hit me up through the meetup group, LinkedIn, Twitter. I'll respond in any of those channels. This will be a recorded event, and some quick guidelines for the call. This, as you join, make sure you're muted. I do believe I have it set so that when people join in, it will mute them automatically, but unless you're asking a direct question, we do ask you to stay muted for the speaker. The way this one's going to flow is Kelly is going to do about a 45-minute discussion and then open it up for questions. But if you do have any questions in the middle and want to kind of keep track of them and make sure they get answered in the end, feel free to open up the chat and put it in there so that we can make sure we everything answered for you. We do encourage video, especially if you're going to ask a verbal question. It just kind of helps to keep a little bit more socially engaging. And with that, I'm going to welcome Kelly. He works for AWS, and he is part of the global SI practice lead in the DevOps segment team. And he's going to talk about the DevOps culture at Amazon.
Hi, everybody, and thanks, James, for inviting me to come and speak. This is a variation on a talk that I give frequently to customers that come to Seattle, where I'm based, that's come to for what we call EBC, Executive Briefing Center presentations at AWS, and this is one of the more popular talks, and they come in for a whole day and they hear a lot about our different services, and it's kind of a big dog and pony show in a lot of ways. And this talk is a fun one because we're not so much selling DevOps at AWS. It's more of a what I find interesting about it is that all of our customers are going through DevOps. They're in the midst of a DevOps transformation, and they are interested in help. They're like, I find a lot of them almost want to grab me by the lapels and say, tell me, tell me what's going on. Tell me, give me some help in how to make things work better. And or even better, tell me how to innovate the way Amazon does. And so that's what a lot of what this talk is about. It's about how Amazon became an all DevOps shop. Now, that's kind of interesting because that's all Amazon as a whole and AWS does, is that we only work in a DevOps way. Now, the interesting part of that is that if you go inside of Amazon, you talk to engineers within Amazon, you ask them about DevOps, they'll probably snicker because they don't talk about DevOps anymore. And this is very similar to what in the past, years ago, I came out of kind of the object orientation, that sort of stuff. If you go to Apple or Google and talk about objects, they were like, who talks about objects? Because that became so ingrained that it became just kind of part of the air that they would breathe at those places, and no one talked about it anymore because it was just part of what they do. And that's the way DevOps is at Amazon. It's just the way everybody does their things, and it's not really a part of how people talk about it. I came to Amazon about 2.5 years ago from having done DevOps with customers for some time. I worked for a while at ThoughtWorks. Well, I came out of the small talk community originally, is how I got started doing kind of Agile before Agile. I worked at ThoughtWorks with Jez Humble and Martin Fowler and others, and learned a little bit about continuous delivery and started doing that with a lot of customers. And so came to the DevOps world from that, and then came to Amazon. And what was interesting to me is that what I saw was a company that from the ground up was built to work in this way. And so that's what I want to talk about today with you all, is a little bit about how that came about, the history behind it, and then how it works with our customers today. And let's see. As you may have seen from the title before, this is kind of how we structure it. It's yesterday, today, and tomorrow. Yesterday is the whole Amazon transformation story. And then we'll talk today about how AWS, rather than Amazon, helps our customers do DevOps. And then finally, I'll talk a little bit about what's the future look like and where's DevOps kind of going. I think it's switching gears a little bit and away from so much purely development and into more how do you operate and how do you run things in the future, and how do you adjust to the challenges of more modern systems. And so I'll talk about that a little bit kind of at the end. And then as James mentioned, we'll do a little bit of Q&A at the end as well. So here's a variation on we have a literal napkin slide that we use sometimes. Jeff Bezos did a typical startup napkin type of a diagram of what he wanted Amazon to be at one point, and it was this sort of innovation flywheel of constantly getting new ideas from customers and giving them more choices and getting more done. And this goes to what he and what the management of Amazon were looking for from their organization. What they wanted was his ability to constantly ask questions. And this goes to a lot of what Agile and DevOps are really about. Too often what I find is that people look at DevOps and they're like, oh, that's about automating things. And what I think they're missing in a lot of cases is why are you the management of Amazon were looking for from their organization. What they wanted was this ability to constantly ask questions, trying to get answers frequently. And this goes to a lot of what Agile and DevOps are really about. As you get
too often what I find is that people look at DevOps and they're like,
how can you get
that's about automating
in front
things.
of someone who can give you
And what I think they're missing in a lot of cases and what the management of Amazon were looking for from their organization. What they wanted was this ability to constantly ask questions, trying to get answers frequently. And this goes to a lot of what Agile and DevOps are really about. As too often what I find is that people look at DevOps and they're like, that's about automating things.
Of someone who can give you
what I think they're missing in a lot of cases and what the management of Amazon were looking for from their organization. What they wanted was this agility to constantly getting answers, trying to get answers frequently. And this goes to a lot of what Agile and DevOps are really about. As too often what I find is that people look at DevOps and they're like, that's about automating things. Of someone who can give you what I think they're missing in a lot of cases and what the management of Amazon looking for from their organization. What they wanted was this agility to constantly getting answers, trying to get answers frequently. And this goes to a lot of what Agile and DevOps are really about. As too often what I find is that people look at DevOps and they're like, that's about automating things. Of someone who can give you what I think they're missing in a lot of cases and what the management of Amazon looking for from their organization. What they wanted was this agility to constantly getting answers, trying to get answers frequently. And this goes to a lot of what Agile and DevOps are really about. As too often what I find is that people look at DevOps and they're like, that's about automating things. Someone who can give you what I think they're missing in a lot of cases and what the management of Amazon looking for from their organization. What they wanted was this agility to
speak for the customer on your team. We don't have product owners at Amazon. We expect every single person on our team to understand the customer deeply and to be able to think in terms of what the customer needs. And one of the things I thought was kind of interesting is that engineers can't get promotions within Amazon unless they have quotes directly from customers as to the work that they've done. So every engineer is expected to interact with customers, is expected to understand customers, and is expected to be able to articulate customer problems. Very interesting, kind of different kind of a culture from that standpoint. Customer obsession is the byword there. These other things are other parts of it. This sort of idea that you're going to try things and you're going to expect failure. I love the one quote from Jeff Bezos who said that if you thought the Fire phone was a failure, wait till you see some of the things that we have in the lab. He says that we're going to keep trying things, and we're going to expect that some of these things are going to fail, and we're going to learn from our failures. We're just going to keep trying things because that's how you make big strides. And we're going to be willing. We're going to take shots, and we're going to be willing to be misunderstood. So a lot of things very interesting here, kind of about the way we do things. So let's kind of look back a little bit about what the situation was at Amazon and how we got to where we are today. I'm going to skip one slide here. In 2001, Amazon.com was a monolith. It was a large application. It was written in Perl. Very interesting how many of the early web properties were written in Perl, kind of thought of as something of a hacker's language. I'm always interested in how many of them, the original ones, were written in Perl. You could actually really get things done in Perl. And it used a relational database, one big relational database, as was the style back then. And it needed a huge amount of ceremony and a huge amount of work to get a release out the door. Every change required the entire thing to be replaced, and the feeling in the organization was that innovation was grinding to a halt, in that it was taking more and more and more effort to change this safely. Because of the amount of testing that was necessary and everything else to update the application. So the thing that happened, and this is somewhat obscured in the midst of legend now, is that something that I call a top-down directive to be bottom-up happened, in that there was a memo that came from on high within the organization, which was a memo that all groups within the organization would start to work differently. And the way they would work is every group within the company would start to use, would start to build their software separately and wrap everything that they were doing in public interfaces. The term at that time was SOA, service-oriented architecture. But the basic idea was that every group was going to build their own independent product, such that any piece of software could be independently replaced. And they were going to adhere to public interfaces. And if you look at AWS even to this day, you'll see that we're tremendously faithful to public interfaces that we put out there. We rarely change them. We rarely make them outdated. We upgrade them and add to them, but we rarely take a public interface away and render software that's depending on it obsolete or invalid. And so over a period of time, this monolith kind of broke into hundreds, and at this point it's now thousands of services, which, because of the size of the teams, this is the other thing that became somewhat famous, is that Amazon settled on team size of what we called 2 pizza teams. The basic idea being that the best size for a software development team was the number of people you could feed with a couple of large pizzas. So, 7, 9, 10 people, something like that. Although that seems kind of too many for 2 large pizzas in my opinion, but hey, opinions vary. But basically, that really agrees essentially with what you hear from the whole Agile community, that size team, anything more than that, and the communications overhead gets to be just way too much. So that's why our SOA services became microservices. And so really before microservices became a term that people were throwing around, we were building microservices because our 2 pizza teams were the ones building services, and they kind of had to be small because the teams were small. And then the other thing that we quickly decided is that these teams were going to build software A to Z. They were gonna start with requirements, and they were gonna build all the way through to operations. And that's why these teams started to work in a DevOps fashion before the word DevOps was really coined as well. So I would say Amazon was already working in a DevOps and a microservices kind of a style well before either one of those terms was coined. The result, and this points out both the positives and the negatives of, I think, modern software, is this huge system of single-purpose microservices that only connect through APIs. It wasn't interesting. There was no decision on high as to what the kind of APIs had to be, what the technology was behind it. It kind of congealed around web APIs, HTTPS. They were largely black boxes to each other. With the internal technology or languages used, there was many of them. The services could be written in whatever, whoever was closest to the problem could decide what technology to use to build the services. But when you look at this, and you look at many new microservice type systems, you get similar pictures like this. I call them Death Stars. There's these giant blobs that are kind of not really understandable to look at. And therein lies the problem with these systems. The advantage of these systems is that they're easy to change and they're quick to change. Any one of these services can be replaced, and it doesn't affect the other services that are there. As long as you adhere to the public interfaces, the system can be changed. The disadvantage of it is try debugging this sucker. It's hard. Try understanding it. This is actually, this one blob here, this is the product of many, many teams. And there's many, many systems actually in here. It's not really one system. There's many systems. And so understanding it and understanding how functionality moves through it is not easy. And this is where new tools, new capabilities are really required in order to understand them. And this is where I spend a lot of my time nowadays, because you've got a lot of companies now that are used to monoliths that are jumping into this microservices world that I'm not sure are really ready. And so that's where I spend a lot of time with customers. So in our, how we broke things down, the thing that we found, our term for these services actually was primitives. And so one of the things that we found was that smaller was better. One of the other things that we found, and this is what caused AWS to start to pursue this idea of purpose-built databases, which now we offer to customers in a great way, but it came out of our own experiences. And our own experiences were that persistence in databases, there were different requirements for different services. The one single relational database didn't make sense for all the different services. Some services, a relational database was great. Lots of querying and that kind of thing, it all made sense. For other services, an in-memory database made more sense, or just a flat file, or a key value store, or different services had different persistence requirements. And so our data domains were different based on the different services requirements. And so it was out of this experience of building different services with different requirements that our whole purpose-built database kind of idea really, really kind of came about. And once again, each of these services kind of operates independently, and there's just purely API contracts between the services. And each of these groups out there is really measured based on its APIs. And it looks at they look at how they do based on the metrics between their different APIs that are there. And these two pizza teams, as I mentioned before, they own the service. Our organization of our company, you hear of Conway's Law. Organizations, software tends to look like the organization that created it. We had to create, our organization is highly decentralized. We have lots of, we have lots and lots of these little small teams. And we give autonomy to these groups to make their own decisions as far as how they build things. And they own everything from planning through deployment, operations, maintenance, documentation, and testing. Werner Vogel, our CTO's famous quote that kind of captures DevOps is, "You build it, you run it." So that's sort of the ethos of the team within Amazon. I think we go further than most organizations out there as far as the dev team staying with their systems and continuing to operate them. And so, how can one team do all this? Does that mean every team has experts in all these different areas? And obviously that can't be the case. But as a large organization, we do have experts in all these different areas in the organization, but many of them are in a mentoring role and helping teams. These teams don't have to be great at all these things. They have to be good enough for their service. And so we do have experts, but they're more in a mentoring type of a role, and they're making sure all the different teams that have the responsibility for these services have the expertise that they need. That's really the key to it. So I talked about this with James a little bit earlier. The net result of all of this is thousands of teams doing work in a microservices architecture, doing continuous delivery, constantly doing new releases to multiple different environments. And last year, it was over 190 million deployments in a single year. And so, you can do the math as far as how many deployments a minute or how many deployments a second that turns out to be. A lot. And the thing I would point out there is that this points to what I think is kind of one of the real secrets of DevOps. Because there's only one way that this number can be valid. Even with as large an organization as we are, that's a big number. And there's only one way that this number can be true, and that is if each one of these deployments is only a few lines of code. And that's the secret of DevOps. And the secret of continuous delivery. The root of all evil in software is a change that you don't really understand.
This number can be true.
It's a change that has ramifications that you don't understand. That's where bugs come from. It caused something that you didn't understand it was going to cause. The change that you made had a ramification that you didn't anticipate. The smaller you make your change, the less likely that is. The more likely you are to understand what the ramifications are of the change, the more likely you are to test for it and make sure that you understand what's going on. So the whole trick to DevOps is to figure out how to make small production-safe changes. And so how to make a big change in terms of many small production-safe changes. That's what continuous delivery is all about, and that's what the secret of DevOps is. That's why the companies that are working in this way are able to constantly change their software and do it in a way that is safe. So that's really the key. So, we hear a lot that that Amazon is customer obsessed. The other thing that I would say is that we are metric obsessed. And these are some of the different kinds of metrics that we gather and that we work with. Whether they're business metrics, operational metrics that we collect, all sorts of different pieces that are here. You'll find, I constantly am looking at different kinds of numbers and different sorts of things that we try to collect. As mentioned, our organization is broken into 1,000 different pieces with all these different teams doing small pieces of software, and most of them are measured based on what's going in or what's going out of their particular pieces of software, and there's metrics on each one of those that they're kind of measuring and looking at. The things that we're trying to do in how we're building software is moving through our development pipelines in a way that we're able to do things securely and safely, while at the same time moving quickly. There's a whole process in place that we do for rolling out new systems that's very very staged as far as the way we build and do new things and roll out new things. We kind of have to roll. We have no choice in a lot of cases but to roll things out into production. We don't really have, I would say, test environments that are completely separate from production. We have to, in some ways, roll things out to production. So we have very, very set ways of rolling things out, such that we roll out and kind of bake in production with subsets of whole regions, and then only go to one region at a time, and then parts of a region, and then promote to a whole region, and then start to go to a new region. There's a whole kind of an interesting kind of a process there that we have got a whole nother presentation that we kind of talk about as far as how we look to do things in a very safe way. The kind of the characteristics of modern applications that we're out there building right now. It's all about, now, microservices, we've got containers around them. We've got, whether they be Docker containers or the sort of micro VMs that we're using for serverless. They've got these attributes of connecting through APIs. We're able to deliver updates continuously for them. They can adapt quickly. They're fault tolerant, can scale. The reason they can scale is that we carefully manage state and persistence and have security built in. So there's a whole set of things here that kind of help define what a modern application looks like. I remember early on looking at, web systems were very, very simple. It was like, web server, and there was a database table, and there was, some processing that went on. The early web systems were very simple, but here's what you're looking at now. They're just amazingly complex. And it's not possible to look at them and really kind of necessarily understand all the connections and everything that's going on. So there's a real need for tooling and help. And this is one of the reasons that we really focus a lot on the proper types of monitoring software and the proper types of additional kind of tooling that you can put in place to help you kind of trace through and grok what's going on with these kind of newer systems. Some of the lessons that we've learned from developing and delivering software. Yes, we automate everything. We mentioned kind of the decomposition. We call our governance and templates kind of belts and suspenders. And then we're, early on, we got on the whole infrastructure as code kind of thing. And I think a lot of the rest of the industry has jumped in with that as well. But that was something kind of early on that we kind of helped pioneer within Amazon. Kind of an interesting development recently for us that we were kind of a little bit behind on, but I'm glad that we've done now, is we're starting to share not just the technology that we have, but a little bit of the practices that we do internally. If you get a chance, check out the Amazon Builders Library. It's something that we announced at last year's reInvent, and we're continuing to add to this. And this is this is not just, as I mentioned before, not just our technology, but it's from our senior technical people within Amazon. It's a discussion of how we do what we do. What are the practices that we use to solve problems and to get things done? How we build advanced cloud systems, and I think that's of great use out there as well. And I highly recommend. It's all free of charge. It's just us sharing with the community a little bit of kind of how we've built systems, and I think that's very useful. So let's switch gears a little bit and talk about kind of how AWS helps people do DevOps. And this may be what a lot of you all are already doing. So I'll move through this fairly quickly. But how does AWS help people, build in the cloud now? I think there's a tremendous advantage. DevOps was around. People were doing DevOps in the absence, before they were using cloud, in a lot of ways. But now I rarely find companies that are doing DevOps without a cloud, because it's just so much easier to do it with a cloud. And so, why use AWS for DevOps? I think the way to think of a cloud is it's this giant list of things you don't have to do. You're able to get started fast. There's all these fully managed services you can take advantage of. They're all built for scale. They're all programmable and automatable. They tend to have security already baked in, and you don't have to pay a bunch up front for them. You just pay for them as you use them. And then there's the part of the organization that I'm in, which is the partner community. Pretty much all the IT vendors out there are making sure that their products work well, especially with AWS. And so, pretty much everything works well with, and they're all working closely with us. And so, I think there's it's easy to find whatever tools you need to work well with your AWS systems. Here's a bunch of the tools that we use internally, and they include our own services and a lot of the other tools that are out there. See things like code build, code commit, code pipeline. They're a lot of the tools that we built for ourselves that we also offer outside to customers. Code pipeline, interestingly, is one of the few that we actually mandate for our teams to use. The reason we do that is that we can build policy in with code pipeline that allows us to kind of make sure that we do things in a safe way as possible. Only put new features out to a single region at once. Things like that. Other things out there is like CloudFormation. If I were to say, two services that we're using to build most of our new functionality in nowadays, I'd say CloudFormation and Lambda are the two ones that we're doing more of them than anything else. I'd also highly recommend that people look at the CDK, the AWS Cloud Development Kit. That's a really, really powerful new development kit that you can use to do infrastructure as code and to develop kind of powerful capability. So these are a lot of the things that we're using internally, and then it's a whole set of different partners. I work with GitLab and Atlassian all the time, Zevia Labs, CloudBees. I've got a webinar I'm doing with them just next week. HashiCorp we work closely with them. Love Terraform and Vault and a lot of their other products. These are all close partners of ours. And then this whole monitoring and logging space that used to be something of a luxury, and now with these new kinds of systems, I think it's absolutely something that is just really something that you have to use to keep up. I think the monitoring and logging has taken on a huge extra emphasis. So let's finish up by talking a little bit about kind of where things are going now, kind of in the DevOps world. I'll talk quickly about serverless. I love this quote by Werner Vogels, and I think it kind of leads to Werner's got a great way of kind of capturing a big idea with a small number of words, and I think that we're quickly approaching much like data centers have become commoditized. I think we're getting to a place where infrastructure management is going to get commoditized, and you're going to let your cloud vendor do that in a lot of cases. And I think that as Werner's saying, there's no server easier to manage than no server. and so that's one advantage to this kind of serverless idea. To me, with applications getting so complex, why take on infrastructure management as well? And so it's kind of worth thinking about there. The advantages I see in serverless is that what you're seeing in writing software for Lambda is it's a bunch of the things that we've been recommending for a long time. I think all the way back to my Smalltalk days. Write everything in small, understandable units of code. Do it stateless. That's one thing we got wrong with objects in a lot of cases. But if you want to scale, do things stateless. It's functional programming folks have really got that right. Consistent networking and infrastructure, event-driven applications, make it easy to author, deploy, and secure. And what you get for free is no server management, high availability, flexible scaling. I mean, those are some super advantages. And with AWS, you've got a complete serverless platform. You've got a whole set of developer tools. You've got a whole set of services that are there. You've got all kinds of stuff. Excuse me. And you've got a broad community of partner tools and partner consultants that know how to use it. It is breathtaking how quickly you can develop functionality and deliver functionality using serverless. Now, I think if AWS was a typical technology company, we'd just say, oh, serverless is the future, everybody do serverless. But that's not how we are. We kind of believe strongly in customer choice. So we also want to offer the best container functionality possible, because we know a lot of customers want and need and are going to work with containers. So we offer two different ways, two orchestration layers for containers. We offer Amazon ECS and Amazon EKS. ECS is what we offer for customers that want to do Docker containers and want to work within AWS and use AWS services with Docker containers. Whereas EKS is for customers that want to have software that runs both on-prem and in the cloud, and work with AWS services. But run straight Kubernetes. So that's what EKS is all about. And then what we've added to that now is this ability to not bother with infrastructure. So AWS Fargate gives you the ability to be serverless with Docker containers. I think that's really interesting because, as I mentioned before, I just don't, this is just me being opinionated, I don't think the future, especially for most enterprise software people, is to be writing code, managing infrastructure. I talk to a lot of people in the Kubernetes community, and there's tons of brilliant people. And there's a good percentage of them that, to me, I feel like they want to build their own cloud. They want to write their own infrastructure code. And it's like, I just don't think that there's a future in that. I would much rather see people addressing application complexity. So there's our different container services, and then let me just wrap up with one last slide just to talk about where we see the future going and where I see operations going. Talked a little bit about containers and serverless, or kind of what things look like. I have this kind of concept, I call it NextOps, which is, I think, going forward, running software without understanding the software that you're running. We've had whole big organizations that have been doing that. Yeah, I just run the software. I don't really understand what it is. I just run it, and I mine the hardware. I think that's not going to be a thing in the future. I think that if you're going to run software, you're going to understand the software you're running. And so monitoring, logging analysis, and observability tools, that's going to be where operations is going to live and work. And I think watching that running software and looking for ways to make it better, that's going to be what your best technical people are going to be doing. And SRE activities are going to be operations job one, whether or not you actually have SREs. We at Amazon, we don't tend to actually have SREs. We do all of that in our development teams, but that doesn't mean SRE activities aren't tremendously important. And so to me, the whole game is get out of reacting to software problems and get into how do you make your software better all the time. And that's really the kind of key. So thanks a lot. I know that was a lot of information in a relatively short amount of time, but I appreciate all your time, and we'll be happy to answer some questions. Thanks a lot.
Hey, Kelly, thanks. That's really good stuff. Hopefully everybody can hear me here. Yeah, we'll open it up for questions. If anybody has any, feel free to unmute. Just a really quick reminder that you're probably muted if you want to unmute and ask, or even ask in the chat. We'll just read it out loud for the rest of the group. So actually, I'll start us off. So I did have a question. If we go back to those, your Death Star analogy with just tons and tons of different projects and project teams. For the business, from an idea creation perspective, especially if it's like a big business idea that's going to have impacts across, multiple teams, how do they navigate that from a business perspective, making sure that all the teams are coordinated properly, everyone's getting the right view on what's going on, and how it's like coordinated and deployed out in like a seamless fashion?
Yeah, there's a real structured process there within Amazon within AWS, and somewhat kind of famously they talk about these things they call these 6-page narrative. They're called narratives, and so you essentially have to build a business plan for an idea. And that sort of gets approved, and then you get a kind of a budget for the idea. And then once you get a budget for the idea, then you start to work on, okay, what are the resources that are going to be needed, and what teams are going to be needed for that, and then every one of these kind of narratives that incorporates an organization will get broken down into different groups, and each one of those groups has their own narrative that they have to build. So it's always this sort of cascading up and cascading down kind of an idea. So we have these kind of sort of status reports that get merged and go up, and then we have the kind of plans that the same way that kind of go down in a way, and that you've got budget, now show us how you're going to use the budget that you have, and it goes down to the teams. And so so it's very interesting, very structured. And but as I mentioned before, the teams at a certain level, it's like, okay, here's your high level charter, now you go figure out what you're going to do with it. And you have to go build a plan of how you're going to achieve the goals that you've been given at your level. So it's very interesting, but every team has to be able to articulate. I've never seen a company in my life that puts more emphasis on you being able to articulate in English, in writing in English, what the heck it is you're doing. No PowerPoint. Yeah, it's all that. So it's very interesting. I guess it's a company started by a book lover. That's the thing.
So then, how do you track? I'm assuming you track the. So once you put some kind of business value and get a budget, I'm sure there's some estimates or some metrics to say this is going to save us X number of dollars or generate X number of revenue. With all and then with all the deploys that are happening, how do you track that from all the way from like start to end and then get that feedback back. Because you kind of talked about it, but I'm just kind of curious if we start from the perspective of, assigning this, hey, I'm asking for so many dollars to put this business feature in that I think will produce X.
Yeah, so I mean, obviously it depends greatly in different, but some of these, as you get closer more into engineering, really you start to build engineering documents that talk about services and APIs, and start to postulate, what are the kinds of numbers that they're expected to handle, and what will those numbers mean? And so those are that's part of the rationale behind what the various services that you're going to build are going to mean. And whether it's a piece of software that's going to be sold, or if it's a piece of software that's going to run and you're going to have so many customers, or what have you. And many of these services have particular goals that they're that they're working. Well, they all have goals that they're working against. There's they're planned at every level.
Hello, I have a question. This is Tanya Riley from Accenture. So of that Death Star, I would imagine that 2 pizza team isn't the actual ops support once it gets deployed and a customer is using it. So of that huge Death Star, how do you get that information out to your ops team on who to contact when an issue happens, or like who should fix it, or where it's coming from?
They are the ops team that does fix it. You build it, you run it. Now there are horizontal ops resources at AWS that run sort of generic resources to some extent, but on an individual piece of software that a particular team has built, there's no throwing it over the wall. You don't give it to somebody else. The teams actually support the software that they built, and so they keep it and they do fix it.
Wait, so you mean outside of the boundary of the service? So if I'm on a team of 3 other developers and my responsibility is that building that service and making a microservice, you're saying my responsibility reaches outside the scope of that service? Is that what you're getting at?
Well, I mean, that's where it all gets very complicated, because when a problem comes about, then there's the whole thing of figuring out where's the problem really reside.
Yeah.
And that's where layers of customer support may come in, and where trying to figure out where's the problem really happening. But at the end of the day, once it's kind of diagnosed, it's the team that wrote the service that's going to fix it.
Yeah. Okay.
And we've gotten really good at diagnosing these things fairly quickly.
It's probably hard.
Yeah, go ahead.
It's probably hard for them not to be be kind of stuck in a silo when you're working on a service and not seeing the big picture. So if all these small little mini teams, you're saying they're really whoa, it's thundering pretty hard on the day of the silence. Everybody understands the big picture conceptually. So you say they're customer obsessed. So even though they're working on a small microservice, they put a lot of weight on understanding the chart of the whole application.
Yeah, I think there's a lot of transparency into where does your service fit in the bigger picture that may affect, for instance, a customer. Okay. I think there's a lot of visibility into how your service might fit into a bigger picture.
Yeah, right. Yes. You brought up a service list. I went to a conference in Vegas, Dev Intersection. I don't know if this is a good analogy, but I think this is what this guy said. He compared a virtual machine to a house. I think he compared a container to a bed and breakfast, and he compared a serverless to a hotel room. Everything's set up for you. You get room service. You think that's like a oversimplified analogy, or that's a good way to dumb it down for like a junior developer like me?
I think it's interesting. The thing I would say is that The problem is that if a VM is a house, then a container is like a shoebox.
Okay, so maybe it's smaller. Yeah, I think the guy at the point it was
really small. It's really light.
Yeah, I think the guy at the point he was trying to get about, like, if you just want to code and build applications and focus on the business problem and you don't really enjoy infrastructure, I think that's what the point he was trying to get across. So yeah, if you compare that to a SU container, it's really lightweight. Yeah, I think the idea is everything's pre-configured for you. You don't have to worry about, infrastructure. You just could focus on the business problems. So that's what I took away from that presentation. I'm like, all right. So because at first I was just like, when I went into that meeting, I was just, I'm building apps the old way. There's a web server, database, API, and I'm like, what's this? All I hear is this buzzword called microservices. What's so sexy about that? And that was like the one presentation. I'm like, okay, I guess the purpose is, like you said in the presentation, is get up and running as quickly as possible, deliver value as quickly as possible, close that feedback loop as quickly as possible. So,
I have the advantage or disadvantage of having been around forever, and I guess for me, programming against a VM feels like programming against a computer. It's just a virtual computer. When I use a container, it feels like I'm also programming against a computer, but wow, it's so fast. I really love it. It's so fast and lightweight. Wow, this is great. Programming against serverless is like there's no computer. It's like, is this like some new age mainframe? What's going on? It's like a whole new beast. That's really amazing and different. It feels, and when I say mainframe, that has a really bad connotation, but it feels like a whole new thing. And the people that are using it are absolutely loving it.
So where do you guys stand with feature flags? I know feature flags have been around a long time, but I've really noticed that there's been a little bit of a resurgence on it for folks
I'm a huge
that are
advocate.
starting to.
I think I think that trunk-based programming is the way to go. We spent all this time with making sure that all our version control systems were great at doing branching, and about that time we figured out that branches are bad. And feature flags are a much better answer because they let everybody work on the same code and everybody tests the same code at the same time. And so I think that's the real answer, because you all want to be testing the same code.
Great. So part B to that question then is, how do you effectively manage them, in the sense that as they go stale or you flip things over, what's the governance on making sure that old code's removed after a period of time or no longer needed, etc.?
Well, there's I don't know that there's a one good way. There's lots of interesting products and technology coming along that are looking at that. Launch Darkly, a couple of other interesting products are out there right now that are trying to address that, because it can create a lot of cruft. You're right, especially as you get into it in a deep way. And so probably something that makes sense to automate. You think about it, a feature flag is just sort of a virtual kind of it's maybe putting the branching where it belongs. So probably something to automate into the code.
That totally makes sense.
Yeah.
So jumping a little bit on topics, going back to our to the developers owning it through development all the way through operations and running it. Is there any mechanisms you guys force or put in place to make sure that you're going through security, you're doing QA, you're doing the right level of testing? Or do you leave that completely up to the development team to manage and maintain and ensure what they're putting out in production has like gone through the ringer?
Well, I think that there's many different sets of governance rules that we apply for different kinds of software within AWS. And so we have different software that has very different requirements around security and around all sorts of things along those lines. So there's different answers for different teams and different software as far as what's there.
So was that some of the governance that you said was around code pipeline? I think it was.
Yeah. Well, one of the nice things that I heard, and I heard this directly from Ken Exner, who runs the DevTools group within AWS, is that code pipeline is one of the few tools that we actually mandate, in that things like pushing out a release to multiple regions at once, we don't want to do that. We only want to push a new feature out to a single region first, and we can ensure that we can make that policy. We can put that into code pipeline. And so that way we don't have to just tell people, we can just put it in code pipeline and make sure that it's enforced there. And so that's something that we can do there. Code pipeline, simple tool, easy to use. It's not a problem. Most people don't mind going in and using it anyway.
I'm a fan. If I go to use it, I just go right into CodeStar and start a project right from there, and it provisions just about everything else out for me. It's fantastic.
Yeah.
Going back to the deploys, I think I figured it out was like 6 deploys per second. If I did the math right. If I didn't do the math right, I apologize. So what does that really encompass? I mean, obviously it's Amazon.com, right? Retail. Is it also like all your data centers, all your AWS services across every region that you encompass, or any insight in what that number includes?
Not totally sure, but I believe it's all the different Amazon companies and all the software that they're developing, all the different products. So it's lots of different kinds of products in lots of different kinds of environments, not just online, but online and offline and everything else. So I think it's lots of different kinds of products.
Back into AWS, front into AWS,
right.
Changes to code pipeline, changes to code commit.
Yeah, all kinds of different software and even products, even hardware products and things like that we build when we're building software. Okay, so we're building all kinds of different software. That's one of the things that why I think it's really important that we start to share more about how we do things, because we build such a variety of software, a variety of systems. It's not like some other folks out there that only build a certain kind of systems. We build a wide variety of software. And so it's useful, I think, for almost any customer can find something we do that's pretty similar to what they do.
Hey, Kelly, is there actually reference projects in that Amazon building library, or is it just like white documents that explain the architecture? Is there actually code you could download off GitLab or GitHub?
I think there's some of them that have projects associated with them. I believe that's right. I think there's some of them that do. If not, there's a lot of quick starts that you can find that do have code that you can download. For the Amazon Builders Library, I believe a few of them do have some downloadable code.
Any other questions that are out there?
I definitely appreciate getting the time to talk to you all.
Oh, absolutely. This is fantastic content. We really appreciate you coming and talking to us. We're real big fans. So anytime you want to come give us a wealth of information, we're open and receptive.
I've got to come back. As I mentioned before, I used to live on Treasure Island, right in your area there.
Yeah.
You probably lived on the calm side. Some shenanigans on that beach.
Yeah. The Isle of Palms, I think, as I remember correctly, which is, yes, on the calm side. That's right.
Awesome. So I'll hang out for a little bit, but just for everyone on the group, the meeting is officially ended, and just really wanted to say thanks, Kelly, for doing this. This has been great stuff. Some of this I already knew, some of it was new, so that was fantastic. Always get a nice little something out of it, so we really appreciate it. If we were all together in a room, I'm sure everyone would be clapping. But being virtual, it's a little different. So,
thanks all. Really appreciate it.
Absolutely.
Hey James, are you gonna upload this video on YouTube or just post it share it on the comment thread of this meetup?
Well, it's going to be up to Kelly, I think, a little bit. So actually, let me just finish the recording real quick here, just so it's ended. If I can figure out how to stop it real quick. So we're going to officially stop the recording. So if anybody had any questions that they just didn't want to deal with being on a recording, now is a chance to ask them. But it's kind of up to Kelly and Amazon. What I'm going to do is I've recorded it. I'm going to give it to them, and I do a little editing just to make sure all the content is relevant and not just like side conversations. Although I think most of it was pretty relevant. I can't think of anything that wouldn't be included right off the top. But if it gets approved by the Amazon folks, we will post it out.
Yep, send it my way, and I'll get them to take a look at it. Shouldn't be a problem.
Okay, awesome. Yeah, and if you guys need to do some editing on either way, we're pretty open.
I don't think they will. They usually mess with my stuff. It's usually fine. I've done this enough. I'm pretty careful with it, with anything that they care about.
Well, we're pretty in depth. I mean, being part of the network and being under MSA and that kind of stuff, I know that like we didn't really talk about anything that wasn't kind of already out there, but this was just a real nice way of being able to put it together and give everyone on the group a kind of a nice way of digesting some of this stuff, and to be able to ask some direct questions, which I think was great.
Cool. All right, thanks. I'm going to run to my next thing. I appreciate it.
Awesome. Thank you.
Cheers.
Cheers. Appreciate it.
Thanks all.
All right.